Okay. Obvious question first. Any Kotlin developers in the house? Unexpected. How many of you worked or heard of Kotlin Poet before? Okay, I was hoping for this because due to the nature of this conference, I can only just touch the topic and you get most of it out of it if you don't know it by heart already. Yeah, thank you all for being here. I'm exhausted, you're exhausted, great conference, last slot. Let's dive right in. Meta programming and code generation is a really large topic. I only have 30 minutes, so before I even started, I'm already running out of time. Maybe I have to borrow a few minutes of your Q&A later. Nevertheless, before I start, I want to share with you the story that brought me here today. Earlier this year at Holisticon, we were hosting the Girls and Boys Day. If you don't know it, it's an institution in Hamburg where 7th graders visit their families, friends, relatives at their workplace to see how adults spend their day and get an impression of job life. And yeah, since we do a lot of process automation at Holisticon, we gave them the task of implementing a process, or more precise, this process, which is a ChatGPT-powered what to cook for dinner process. So basically you send an email, 3 friends are coming over, 1 is vegetarian, I like chicken, and then ChatGPT will suggest a meal and even give you a grocery list for the items you have to shop. And also the kids started playing around with translating this to French or Spanish. Important. Also, this is a toy project. The technology behind this is pretty amazing, this connector and prompt stuff. Go check it out if you're into process modeling or AI in general. And what I just yesterday learned, if you saw the presentation about the kitchen robots by Lovis from Circus, I mean, suggest a meal, shop the items, and prepare them with robot arms. That brings us close to Star Trek replicators, T. Grey, hot. So this is pretty amazing, but not what I want to talk about. So the kids were sitting there a couple of hours, implemented this process, and it worked. So they could send an email. They got a result from ChatGPT, what to cook, how to cook it, what to shop. And we were all pretty excited. The kids were proud, and we said, wow, this is so cool. Great time to be alive. And yeah, this was amazing. And then I went home and said, wait a minute. I mean, a bunch of 12-year-olds just built a running process application that fulfills its purpose, deployed it to the cloud, and executed it. This is my job. Yeah, this is what I do for a living. If kids can do this today, give it another week or another year, and my managers and clients can do this as well. And then I die starving in some gutter. So I went to sleep, frustrated and frightened. And then I woke up the other day and said, wait a minute, I didn't see any food. I mean, we were so impressed by the shining emails and recipes and shopping lists and everything, but does it taste? Is it enough food for 3 people? Can I even cook the meal with the items on the grocery list? So how, if we boil it down, how can we reduce manual coding but keep up the quality? So then I noticed, if even, there will be more work for me. Yeah? I have to ensure this in the future. Of course, I have to reduce manual coding. I cannot no longer charge 3-digit rates for implementing stuff that any kid can just copy and paste. But I'm the one responsible to make this whole generation software process deterministic, reproducible, and scalable. So My idea, at least today, is that the best way to control the software generation process is to write the generators ourselves using our experience in software development. And that's how I came to this conference. I filed this abstract. You probably read it. Now you're here. Thank you very much. The irony, I didn't even write this. ChatGPT wrote this. I only came up with a title line. Okay, let there be code. First, obvious, few words about me. This is how old I am. This is a reconstruction of the first program I ever wrote. If you cannot read or understand German, it basically says Simon is stupid, and if you type run and press return, it will just keep printing this. It was a great way to annoy my little brother. This was written in around 1986, not even on my machine, but on a display machine in the warehouse. A lot of time has passed. Now I'm here today. I'm a senior consultant for Holisticon, IT and management here in Hamburg. I have, I don't know, 20-something years of experience in professional software development. And I'm a huge fan of Kotlin, as you may be. But, and now you can leave in outrage, I don't do Android or native or anything. I use it as a Java replacement in the backend for my Spring Boot applications. I still, at least for my enterprise projects, prefer Maven over Gradle because my colleagues cannot mess it up. Thank you very much. And we'll see if you keep clapping, I might be the last one on earth who uses the light mode. And it's a pity that it's called the light mode. It should be the mode. Yeah. What we're going to do today, we do a bare minimum of theory, so this qualifies as a conference talk. Then we spend most of the time with our hands in the IDE, or more precise, I will do it, you will watch it, and then we ramp it up. Sounds fine? Cool. So, what is meta programming? By the way, do you know this picture? This is how my brain works. This is Lake Tal in the Philippines. It's a lake on an island, in a lake on an island. So now we covered meta. You already know programming, so we can go on. This is copied from Wikipedia. And so meta programming is a programming technique where computer programs have the ability to treat I didn't like other programs as an input. I think the most important thing is here that program doesn't mean the executable code, but also your documentation, your diagrams, your specifications, your database schema, so everything that belongs to the overall software product we are building. And I made this highly scientific diagram. You can basically, on the JVM, of course, distinguish between source code side and bytecode side, and compile time and runtime. If we go counterclockwise, source code generation at runtime, I didn't have any use case for this. If you do bytecode modifications at runtime, this is basically called reflection. This is what Spring Boot does a lot. So all this JPA repositories and dynamic proxy loading and all this stuff. GraalVM, for example, on the compile time bytecode side, solves this problem by avoiding reflection and compiling this into the code before. And the most interesting quadrant is what's called code generation. This is where we actually generate source code that we ship with our application or pass to our compiler. Okay, we can have annotation processing to generate our code in this upper quadrant. Abstract works this way, so I have an annotated class and a compiler plugin recognizes this annotation and does it work. You can just use command line tools. For example, the basic implementation of the OpenAI REST generation is a command line tool. And I think what we all like best is included in our build. Again, OpenAPI is an example, and Afro, which we will also see later. Tools for source code generation. The source code is an ASCII file, so I could write just a file. I can use string concat if I want to. We don't do this. Very popular are template engines, Moustache or Velocity, for example. And you can use, and that's the reason why we're here today, language API. So write code that writes code. I started working, I don't know, 15 years ago with the Sun code model, which is basically not existing anymore. I worked with Spoon, which is really cool for the Java side, and Kotlin Poet. I don't like templates. This is the actual Kotlin data class template of OpenEye to generate a data class for a REST specification. And we had to fix something inside. No, not enough money in the world to pay me to do this. Okay, Kotlin Poet. This is their website. You basically cannot find that much information on the internet, besides the obvious Bedlong article, how to use it, of course. But you don't really need to, because this is a one-page documentation. It's big with examples, and it's really great information source. It's implemented by Square. You might probably know Square. They are also the inventors of the OK HTTP client or the Moshi JSON processing. And they have a Java Poet for this other language that also runs on JVM environments. Okay, then let's have some fun. Of course, when we start a new language or a new programming technique, I will implement a hello world for you. This is just an interface with one method, hello world. And I prepared an empty class. I will do this inside a test framework, because we later can then test if that what we generate is actually correct. Basically, of course, I could just use a main function now. Say hello to code.talk audience. Okay, first thing we do, we give the thing we're going to generate a name. This is a class name, package, code.talks. Name, I don't know, say hello to audience. And then, basically, Kotlin Poet has a very limited number of specifications, and they use Builder to create these. So we are implementing a class, which is a type. So we will use a type spec and build a class. We already have a name for this class, and we type build. And since this generates code, we can just look at the generated code using this highly sophisticated debugging tool. And run it. And we have a class. Stay calm, it's getting more exciting. We want to implement the hello world interface I just showed you. So we implement hello world. And what else? We add some documentation. This is now the part where even Kotlin Poet cannot work without some kind of templating. So Kotlin Poet helps me with the language constructs, methods, parameters, properties, all these things. But what's actually inside is handwritten. There's no generator for an if-else block or a loop or something like this. And this L just says take the input. It basically works like the string format operation. So I type what I want to have produced, and then I just add parameter, and this is simple hello world class. Let's check it again. Cool. We have a documented class, and we're implementing the interface. If you wonder why this doesn't look like your normal IDE, this is just the type. When we create it and save it, we put it in a file. So we say file. We use a file spec. We just by convention, we can, of course, in Kotlin, we can use any name, but let's stick to the regular thing, and we add a type. And this is the type we want. And since it's the builder, we build it. Now we look at the file. This is. So now we have this stuff we really want to see. So it recognized the imports, it shortened the full qualified names, and it starts to look like code we can work with. And obviously, this just claims to implement Hello World, but doesn't implement Hello World. So now is a good point to start testing the output. If you don't know, the Kotlin compiler basically is also just a jar on Maven Central. So I could just use this code here to compile it using the compiler, but I prefer using a wrapper library, Kotlin test compile, which gives me a bit more access to. But basically, we could now just say, compile this code, please. So we are here. Let's print it no matter what. And we say we have a compilation result. And that's, I think I called it Kotlin test compile of my file. This is just some shortcuts I built so we can skip all the setup of the testing library. And then we can assert compilation OK using the result we got. And we're expecting some mistakes. Yep. And it tells me what went wrong. So it's not abstract and does not implement the abstract number, hello world. So a method is missing. So let's add a function spec named hello world. And before this is taking too long, I also say it returns a string. Let's test it again. Expectations, will it work? No. Because now we are hiding the member of the supertype, we must add override, and of course we must add some actual body for this function. First the override stuff, add modifier, override, and then we add code. And this is basically just return, and we return a string. Templating thing we already discussed. And we return hello code talks. Typing is hard. 2023. Switch screen. Yeah, now we're green. So this is the code that fulfills the requirement of the interface. And yeah, you saw a lot of building blocks how Kotlin Poet works. Remember when I told you that I have no real practical application for this upper left quadrant? So generating code at runtime. Well, I found something we can do, because we can say, now I have a generated class, and I can get the class loader and load this generated class. I think it is file, just full qualified name. And then I can use reflection to say I have an instance, and I want class get constructor new instance, and I know it's a hello world. And then we can print out what we actually wanted to do, hello world, plus some extra surprise. Done. So you might wonder, who was this crazy guy who told us to write hello world and 20 lines of generator code? We have a couple of minutes left, so I show you what I'm actually doing right now, and this has to deal with Avro, schema specification, Axon framework, Axon server, CQS stuff, so we will just touch it briefly. Who knows Avro? I know, Simon, yeah. So this is a protocol specification written in JSON, which actually defines a contract now that I can have some message or method find talks by keyword. I give it a keyword in the request and then expect code.talks talk as a response. Actually, I have a Java generator maven plugin to generate working code from this. We use this in our project, but I mean, it's a bit unfair, but this is the Java code for a data class used as return type of this specification. We can do better. So, yeah, this is the code I wrote. When I work with the Axon framework, think of just some messaging infrastructure. The code that I need to write is I use a query gateway, just one of the main interfaces they provide. I have to send a query. I have to pass an instance of a query object. So a string is not enough. It has to be something wrapped, full qualified. So the routing can be done on reflection level. And I have to tell my request in this response types block what I expect back. So this is a single instant, but I don't know if I mentioned this. Here, I defined that I want an array, so a list of possible talks. And it's really annoying that when you write the client side of this query gateway, that you have to know how the query handler on the other side implemented this method. Normally, in our project, because we also control the query handler side, we look in the code and see, okay, this method returns list, so I know I have to use this here. And I want to have a generator that does it for me, avoids all this Java class stuff, and gives me exactly this query gateway method I need. We can just have a short look. Is it big enough for you to read here? So this time I just use a main method to do so. I'm parsing the protocol, the JSON, using the tools Avro Java provides. I then extract this message just for brevity. Normally, of course, I don't know how many messages are inside the protocol, so I would loop over every message and generate code dynamically. Then I said I have this request. Where's my pointer? There. I generate a data class object for the request and for the response. I wrap, because I know it's an array. Again, this should be dynamically. I wrap the return type as a parameterized type name of list. So this is how we deal with generics in Kotlin Poet. It's a list with response first, so the type of the generated data class. And then I provide an interface for the query handler side. So the provider of the code.talks gets an interface. You must implement find by with query parameter and return value. And I generate the client side I just showed you. Skip. Okay. And you see that now I have really nice small Kotlin data classes for request and response. I have an interface that the provider side implements, and this is a really cool option of Kotlin, because normally in this code generation, quadrant we were talking about, you cannot modify existing code. But with Kotlin, we can provide extension functions to the Java framework classes I use. So from now on, instead of manually wrapping together the response type, I can just call on my query gateway, find talks by keywords, give him the generated class, and I get back nature of axon, a completable future of a list of code.talks. So, and this in a bigger scale for every possible schema variant, multiple messages, everything. This is what I'm really working on, but that's nothing I wanted to show you today. Okay. Then we can go back and draw some conclusions. I'm really faster than I expected. Cool. Gives us more time for questions. If I argued why I think writing code generators is a good idea, but I mean, you saw the Hello World example. It's not free of cost, and you have to consider some best practices. So carefully choose what to build it for, what not. Obviously, a general purpose generator for a schema language to your client and provider code is a good use case. Hello World is not, so choose before you start. And if you do, you can really benefit from reducing boilerplate code. So all I have to know is now in one extension function. If you generate this, you do not have to share a library, some util helper stuff between your teams or your services. You just use this one Maven plugin, which reproducibly just in every system you build does its generation for you. So doing onboarding, new colleagues don't really have to care how I wrote this generator. They just have to know that they can use this query gateway extension. And this reduces my mental overload. So this is just stuff I generate, I trust my generator, I test my generator, and I'm never dealing with this concern anymore. Some best practices. We talked about that this is just a proof of concept. Normally now I would build a Maven plugin and or an annotation processor. For example, just an interface annotated with the path to my protocol resource could then generate this code during annotation processing. So you should build your generator code agnostic of if it's a Maven, a Gradle plugin, or annotation processor. It should just work with its own API, and then you can decide how to use it. You don't have to focus too much on the readability of the generated code. The API should be precise and readable and easy to use. It doesn't matter if you generated 1,000 lines of code. Good example, which I noticed, someone just implemented all basic math operations for numbers from 0 to 100 by generating an if-else statement tree. So this solves the problem. You don't look at it, you don't care. Might be a good option to save computation time on a deployed system. So focus on the readability of the stuff you give to the user, not what's in the backend. You might have noticed this test ran rather slow because the generation, the printing out of the class is fast, but starting the compiler, compiling the code, and then analyzing it takes a while. So what some generator Maven plugins do, you can basically create a hash and then say, okay, if the input didn't change, and I have a hash for this, I do not generate the output. I just trust that I can keep my previous run. And what I sometimes do, so this is maybe not the best practice, but a good practice that works for me, especially in Maven modules. You can put this in an extra module and then just do a Maven clean install once for this module and later just use it as an import. So it's not run every time you compile your real application module you're working on. I think that's all. So should you use Kotlin Poet for code generation? My opinion, yes. 30 minutes, perfect.